We're going to move on to a primordial pond. And at this pond, we have a pressure at the top of 1 atmosphere. We know if we go down a distance of 10.3 meters into fresh water, we double that from 1 atmosphere to 2 atmospheres. Now, this pond has a nice underwater cave. Kind of fun. And my question is, what would the pressure here be? Would it be 2 atmospheres, greater than 2, or less than 2? Now, another way of asking this question is, if I were to drill a horizontal hole through the rock with a long drill bit, after the hole filled up with water, would water stream to the right through the hole, or stream to the left through the hole, or just be stagnant in the hole? What do you think? Oh, I think it's Friday. Yeah. It wouldn't go anywhere. I would have the same pressure here as there, and that is one of the most powerful parts of our formula. This was our formula, remember, that the pressure at 2 is equal to the pressure at 1 plus rho GH. Never at any time did we care what shape this container of liquid was. It doesn't matter. All that matters is how much deeper point 2 is than point 1. Okay? Now suppose, this is just kind of off topic here, but suppose that there was a villain, an evil villain, and he had his lair down here. Okay, and so this is all water. And this is air. And he's got a little dock here. He's got henchmen that are ugly. He's probably got a submarine. They usually have submarines. And the question is, if that's 2 atmospheres, what's the pressure of his air in his evil headquarters? It's got to be 2 atmospheres. It's got to be pressurized. And if that supervillain says, you know, it's starting to stink in here. It really is. All you bad guys are just not taking showers. It stinks in here. And so he drills a vent to get some fresh air. What do? Yeah, we just flush out all the bad guys. Nice technique. Okay. So, I got to tell you. Yes, sir.
That little corner there in the cave, what if it was just like a pocket of, like you brought the little thing down?
What if it were down here so it was just a little hole?
No, like it was completely covered. And it was like
if it went all the way down?
Yeah, it was like a pocket of water down there.
Oh, in that case,
would it go back to the
it really depends on how you put the water in there, at what pressure you put it in. At that point, I can make the pressure anything I want up here, and then from there I'd use the formula. But if
you did it suddenly, would it be then
if I just went straight down, all of a sudden this just grew down, then this would be still 2 atmospheres, and whatever, you know, if I went 10.3 meters below, it would be 3 atmospheres. Have any of you been to Cancun, to the cenotes? Any of you? Okay, down in the Cancun area of Mexico, they have an underground river that just kind of runs under everything. And every now and again, the ground just falls in, it just caves in. And you've got a sinkhole. And if you go down in that sinkhole, there's just beautiful crystal clear water. And if you look under the edges, there's all these stalactites. And if you look down below, there's stalagmites. You're in an underwater cave. And what my family would love to do when our kids were in high school is we'd go down with flashlights, and you'd dive down and you look up for air pockets, and then you'd go for the air pocket and you're in a little new cave. And then you'd go down and look for a new air pocket and you're in a new cave, as long as you remember where you came from. One year, we were there, my oldest had just gotten married the year before, and brought his wife, And we went to a new cenote that had just been discovered. The farmer just found it on his land, and someone told us about it. We went out there. Gorgeous cenote. And we spent time there, and after a while, we noticed that it had been 45 minutes since my oldest two boys had been seen. They were gone. We searched and we searched and we searched. We couldn't find them. My son's wife was just getting frantic. She was panicked. And then, after an hour and a half, my two boys came walking through the jungle. What had happened is one of the boys had looked down, seen some light, and went through a tunnel to get to it. It was a long tunnel, just barely had enough breath to get to it. His brother, not wanting to lose his brother, went after him. They got in there and they thought this is a way cool cave. But when they went down to go back, there were all sorts of different holes going every which direction. And they kept going down these holes and they couldn't find out. And so they just didn't know what to do. And finally, they climbed up the walls of this cave and dug themselves out like zombies out of the top and came marching back through the jungle. So we almost lost them. Okay. It turns out on this particular day an asteroid lands, and because of that crash, it sends a shock wave. The monkey is dead. Okay? It's a big enough shock wave to send the pressure at the top from 1 atmosphere to 5 atmospheres. Now the question is, what happens here? Does that go to 4 atmospheres or does that go to 6 atmospheres? What is that?
6.
Okay. And I should have said 6 or 10. I'm sorry. It goes to 6. And that's because I'm adding 4 atmospheres to the right-hand side of this equation. The density of the water doesn't change. You're on the same planet. The depth stays the same. Whatever I do to the right-hand side of the equal sign, I got to do to the left-hand side. And so this has to go from 5 to 6. Now, I don't have to use an asteroid, okay? Waiting around for an asteroid is kind of boring. If I just get me a giant and a plunger, if my giant is big enough, there's no limit to how hard he can push on that plunger. And I can make whatever pressure I want at the top of that surface. That pressure at the top of the surface is going to be transmitted throughout the liquid. The first person to actually verbalize this was a scientist by the name of Severus Snape. No, but he does look a little bit like Severus, doesn't he? This is Blaise Pascal, a mathematician, and he said any change in pressure applied to an enclosed fluid is transmitted undiminished to all parts of the fluid and the enclosing walls. This is the very foundational principle of hydrodynamics, of hydraulics. In other words, this is how all of those great big huge pieces of equipment on the farm work. Okay?